Topic of this talk is server state management, ways of managing state in our application. So I'm going to talk about the definition of the problem, some mechanisms that are old school, if you will, been around for a long time, but they are portable. Talk a bit about this notion of conversational state, which will become even more important as we move forward, and then some best practices for doing so. So what's the problem? The problem is HTTP is stateless. The definition I want you to know is the response to the current request does not depend on responses to previous requests. So each of those independent requests, if you will, are handled by the server independently. But we know when we write programs, typical desktop programs, mobile app, any kind of application, that the programs we write are usually stateful. We keep that state usually in variables, right, in memory, and sometimes we leverage things like the file system or external databases to have a more persistent notion of state. We're used to doing things where the results of what we do, the computation we do, is based on prior results. Think of the calculator example. You know, we compute a number and then we go add another number to it. The response to that addition, if you will, is going to depend on what the previous total was. So we're just in a normal mindset in application development of being stateful, but the underlying protocol of the web is stateless. So we have an impedance mismatch problem. The protocol expects each request response pair in that synchronous protocol to be independent of any other, but our programs want to rely on a dependence of prior info. So we have to provide it, all right? So we have to build in the statefulness that we want. Now, when we talk about statefulness, there is more than one type of state relevant to web application development. The first is what's called application state. That's the life cycle of your application process itself, the process running in your process table. You know, the application could die. The application could be replicated across many nodes in the cloud. It could be restarted, but you want to recover back to where you were. So application state here means the state of a running process on your system. There's user preferences state. User preferences state is understanding who the user is, what they typically want to do, and how they want to interact with you. The user preferences state is usually a profile, right? Something we know about the user once the user is identified to their application that indicates the kind of preferences, the kind of things that they like to do. Simple example is if you use something like Gmail, you may have picked out a theme, right? The dark theme, the white theme, and so forth. Those preferences are remembered in some way so that the site, when you come back to it, remembers those preferences and displays things the way you want them displayed. There's a notion of world state. World state is actually independent of any specific program. It is not an application-oriented state. It's not the memory of variables in your running program. World state refers to domain modeling and the things that are typically stored in non-volatile storage, like a database or a file system. When you do that, typically you can write many applications to talk against the same database. A mobile app, a web app, desktop apps, and they all share the same database, so they share that same notion of state. It's called world state or world model state because it's supposed to be the system of record for your organization's understanding of the world at any given point in time. And so you did this in database class, you had transactionals, semantics, and things like that. That database is meant to scale and talk to many different applications at once. So it's not just relevant to your own. But the fourth kind of state is the one that we're going to be most concerned with, and that's conversational state, and that's kind of the topic of this talk. It deals with trying to add that stateful layer on top of the stateless protocol. Example use case to try and explain that further. So the classic use case is the shopping cart, right? You go to an e-commerce site, a travel site, a site like Amazon or eBay or something like that, where you're going to buy something, buy some product, buy some service. You typically go to some landing page. You may or may not authenticate. It may recognize you. All right, you go to GitHub, you go to Amazon storefront. It recognizes you from before, even if you haven't put in your password yet. Right? That's typically done via cookie, which you've learned about and is more of a form of personalization of user preferences state. But as we browse and select items, we put them into a shopping cart, right? Now the thing is I may be putting things in a shopping cart and you may be putting things in a shopping cart, but we're not putting things in the same shopping cart. So we are each having our own logically distinct application semantics with the server that's maintaining the things that we're browsing and putting them into the shopping cart. So when someone selects an item and put it in the shopping cart and that HTTP request is made, which shopping cart, right, is it going to go into? So another way to think of this, I'm going to draw it, is we've had this, you know, our model of the web right now is kind of this page turning model. What we mean by that is we start on the, let's see, I'll make the browser here, the client side, and we have the server. And the browser makes a request and the server responds, and browser requests, server responds, and the browser requests and the server responds. Each of these is an individual HTTP request going this way and a response coming back this way. Okay, it's not direct calls or invocations. We don't call things, if you will, between these things. They're going back and forth. Now the thing is, this is going on for one server here, but now there's many browsers. I got another browser here, and that browser is also making requests to the server. And at different points in time, I'm drawing it as if time is going this way. So the overlap of these things may vary. Okay, and at some point, one of these requests here, this request here, and change my color back, and this request here may represent putting things into a shopping cart. But the thing is, this user has a shopping cart. That may be me, and the fuchsia, if you will, may be you. This is a shopping cart. So when a server gets a request to put something in a shopping cart, it can't just put them in one memory store of a variable called shopping cart. It's got to have a representation of a shopping cart for me and a representation of a shopping cart for you, so it knows who's buying what. All right, that's the issue. And we call that conversational state in part because it's as if each browser representing each individual user is having her or his own conversation with the server as if they had the server to her or himself. But really they don't. The server's serving all requests, and on top of that, each one of these requests is stateless, so it has nothing to do, right? This one has nothing to do with this one, this one, this one, and so on, right? They're all independent. That's what it means to be stateless. So we're having to layer this stateful semantics over, and that's called conversational state. Problem two, how to remember what the user browsed for before or what her or his preferences are. Maybe the shopping site knows that I like the Red Sox, and maybe it thinks that you like the Diamondbacks. Can it remember that so it recommends certain products? All right. And how does it even identify when the browser opens up that it's me who's coming versus you? All right. We may use something, the typical mechanism is to use cookies for that, because those cookies are stored in your browser and sent with every subsequent request up to the server. Problem three, how do we access the inventory? Now the inventory of the store is stored in a database somewhere, and that database is independent of our specific web application, right? We may have the Amazon web application, we may have the Amazon mobile application, we may have the storefront's desktop application, we may have an Alexa, right? All those have access to the inventory to ask things about it. That's world state, is independent of any individual application, and the actual number of products that I have is a feature of the real world, if you will, and that's why we call it world model state. Last problem, what happens if the application crashes in the middle of your interaction? You're going through the shopping cart and you're browsing and you're putting things in the shopping cart, and all of a sudden it crashes and you have to restart. All right, what happens if a new version of the application comes out while the users use it? That's another situation. We're writing these web apps all the time, and we're always rolling out new features and improvements. Well, what if somebody's in the middle of using the app while you actually roll out a new version, right? That can happen. I can be in the app and, messy as anything, but right in the middle of these conversations that we're having about buying products, boom, the server says I got a new version. What do? Do you cancel all the shopping carts? Do you even tell the user about it, or you maintain the shopping carts and those conversations that are going on even as you're rolling in new software on this side? All right, challenging stuff, okay? Okay, so those are the nature of the problems. And again, I'm talking about each one, but the one we're focused on today is this notion of conversational state. Conversational state, the definition, and I want you to know this definition. A conversational state represents a bounded conversation or interaction between a client and a server. And a web application may support the creation and deletion of several conversations during a single user's interaction. Which means, yeah, I mean, I can have this conversation going on and have multiple users, but I could also have get a clean page here. I could also be one browser down here and one server, and I could have a conversation about one thing. That's a shopping cart. Maybe that same site has a different set of services related to travel. All right, I can start a second conversation from the same browser about travel. Okay, so I get multiple conversations going on at once. Typically, though, that's not a normal use case. Sticking with a more sorry, I thought I was erasing there. I'm still not erasing. Now I'm erasing. More typical, what happens, because that's kind of an edge case. The more typical case is I go on the site and I buy something, right? So you bought something on the e-commerce site, you enter your info, you browse products, you do payment information, right? And so you do this interaction between things, and that interaction, you know, this represents the steps, right? You browse products, you select certain things, you buy certain things. That conversation is bounded in time. It has a beginning and an end, and when you're done, you're done. Which means when you go out here, if you want to go, maybe you got done buying something, it said, okay, click done, and it sent you back to the storefront, and you said, oh, wait a minute, there was something else I forgot to buy, and I wanted to buy it. Where you have to go back in and go over and do a whole new conversation. That's all happening while you, as a person, are sitting at this browser doing stuff. All right? Which means you actually had multiple conversations, and each conversation was bounded in time. A certain set of interactions, requests and responses going back and forth, that had a beginning and an end, and another beginning and another end, and another beginning and another end. All right, it's not just like I kept the phone call open the whole time. I hung up and then I called back. All right, looking for a new conversation to do new stuff. Okay, so that's what we mean, a bounded interaction between client and server, and that there can be many such interactions that happen. Okay, now how do you solve conversational state from an application architecture standpoint? You're writing an application, and now you've got to put the state somewhere. And you can put the state on the web, on the client, or in the server. And really, you can actually put it in the protocol, meaning you can put it what's called in band. But we basically got to decide where we're going to put stateful information as we write these applications. The mechanisms for managing conversational state are these. The first three have been around for a long time and also have alternate uses. The real way you do it, by the way, so this is a setting the stage lecture, the real way we're going to do it is we're going to use something called session-oriented middleware. And there's session-oriented middleware and different notions of session-oriented middleware on different platforms. Java has one, Node.js has one, or Express has it. There's, any web platform you go to. You want to go use Python, you want to use Django, something like that, Ruby on Rails. There's a PHP has sessions. They all have this notion of what's called session-oriented middleware, which use session as kind of an alias for conversation here. There's also the notion of using something that's more connection-oriented, like SSL as a security protocol. We are not going to worry about that one right now. And that's not really what SSL is intended for anyway. You're really just kind of piggybacking on something else. The mechanisms that we want to focus on today are these, 1, 2, and 3. Hidden form fields, URL rewriting, and cookies, all of which have been around for a long time. The next question we got to ask is, are we going to store that state on the client or the server? If you have information on the client, that means as we go back and forth, going back to here again, as we go back and forth between things, we're basically going to have to transmit the stateful information to go back and forth so we don't lose it. All right, that's what we're basically talking about. That's one way to do it. The way that does, and that's called in band, the blue line, and that's because we use things like hidden form fields, or we can use URL rewriting to transmit the information on each request response so we keep it. Another mechanism is to use cookies, and we know that cookies are set by the server, but persisted or stored in the browser. So they're sent this way on a response, and then from there on out, they're sent each time there's a subsequent request is made by the browser, and then the server can modify them on subsequent responses if they want. Or we can choose to store it entirely on the server and simply have a mechanism by which we go back and find the right conversation each time a new request is made, meaning we have to understand where it comes from. So that's what this is meant to convey. When you do it from the client or in-band way, some mechanisms you might have are things like, as I said, a hidden form field. A hidden form field looks like this syntactically. This is an HTML file, right? It's buried inside a form action, and I can put things like, you know, is it really secure? No, of course not, to put first name and last name inside the hidden form field. If I do that though, and when I send the request from the browser to the server is going to have it either as query string parameters or it's going to be in the payload, right, if it's a post. So I'll be able to retrieve Joe Schmo when I do the request parameter processing step of my template pattern. Same thing with URL rewriting. URL rewriting says I'm going to put this information, this stuff, on the URL itself in here and encode it in a particular way because I can read information off the URL. And so sometimes when you go to the web, you see really long obfuscated URL strings appended at the end of the host server name and a relative path. That's a form of URL rewriting. You're encoding information directly on the URL. The benefits of these two is these two are entirely portable. They've been around since the beginning of the web, and no matter what browser you're using, these will always work. That isn't the same, necessarily the case for some of the other ones. Cookies, for example. So we've already done cookies in the class, so I could store a cookie that has F name and L name on it in a cookie on the browser and then just send that every single time on subsequent requests. One thing though is cookies aren't fully portable because you can turn cookies off in the browser, right? You can say I don't want to store a cookie for this particular domain if you're the end user, which means the end user could get involved and actually make it such that your application semantics won't work by turning off cookies. Not very common nowadays, but it can happen, and you have a browser setting that can do that. The second thing about cookies is cookies are going to be longer lived than this bounded interaction. Again, we want to talk for a certain amount of time, beginning, end, and end the conversation, right? When I pay for something on my storefront site, I enter my credit card and other sensitive information. I don't want that sticking around, right? I want when I buy it and the thing says, congratulations, you're done, and your order is being processed, it's on its way, or whatever. I may leave the computer. I don't want somebody else to get on and turn around and hit the back button and go back into my workflow and be able to take my credit card information or buy a whole bunch of other stuff, right? Or in some way mess with things. So I want that conversational state to end and never be around again. But cookies don't end if we have a persistent cookie. We have to programmatically remember to make it end at the right time, and that is subject to application programming errors. If I start putting this stuff in here and I put other sensitive information in here, what if that cookie stays around? All right, that's part of the issue as well. That's what I mean, by the way, is not tied to flow. It's not tied to the conversation in any way. So unwieldy means it could get hard to maintain or represent. Okay. What about server-side state? Server-side state says instead of putting the actual values and things like this, to go ahead and put those things as some kind of identifier. Right? Here's an identifier: hidden name equals ID, value equals 1, or on the URL like this in URL rewriting. All I got was an ID. That ID is going to correspond to the state of a conversation, and then there's going to be a big map stored in Node, or again, any other platform. I could have, again, Python, PHP, Java, whatever. And now I can look up that particular ID, get the state, and the state will be an object that I'll have the sensitive information in there. The nice thing about that part is the only thing that goes back and forth in my back and forth flow here is an identifier that only has meaning as a key into a map in the server, meaning it never goes over the wire, so it can't be sniffed and pulled out of there, if you will. Now, can somebody try and steal the ID and use that to access information? Yes, they can, and that is a security hack called session stealing. But there are some mechanisms in how cookies are managed underneath the hood. And by the way, I say cookies because actually cookies are typically the mechanism used by third-party packages that manage sessions or conversations for you. That's session-oriented middleware I was talking about. The underlying default implementation is to use cookies. The backup implementation is to use URL rewriting because, again, somebody might turn cookies off and then you wouldn't be able to have that session-oriented middleware. So instead, you could use as a backup URL rewriting. All right. But one of the benefits is if I never put the first name, last name on the wire, there's less chance that it's going to be a security hack on it. Okay. Now, that's one of the pros. One of the pros is security. Another pro is less information back and forth, not quite as unwieldy because I'm not taking all the raw values and shoving it in there. I'm just sending one value and I'm maintaining things in the server. It's also a little bit more reliable or robust, right? If your browser has problems or there's a blip, I still have the state on the server, and I can. There's mechanisms for persisting the state, like your browser crashed, you come back, it still knows about your shopping cart kind of thing. That you can all do if all the state is on the server, that you can't do if it's being sent back and forth as part of this flow. There's of course other risks. There are certain kinds of security problems, but the biggest problem with server-side state management, if that's what you choose to do, is there's an overhead. These typically are done as maps. Sometimes they're maps backed by a persistent store, so they are longer lived. But as an in-memory store, you're using more computational resource on the server side. Usually they take up a lot of memory or perhaps a lot of database connections because you're storing all the stuff here. If I didn't store it here and I just send it in band back and forth like this, I don't actually have to store it. It's coming in with each request. All right. There's examples of this. I already said this is, again, number 5, session-oriented middleware. Here's what it looks like in Java. Just to give you an idea of what it looks like. There is an API built into the servlet specification that creates for you, the container creates for you in that container component model that we know servlets are, a way to get the session from a request object. There's an object that represents an HTTP request coming in. You can ask it for the session. Why are you asking the request? Because it probably used either URL, or had to have used either URL rewriting or a cookie underneath that came in with the request. It can then use that, get the identifier, look up the session object. The session object then has a set of attributes in it. It's basically a glorified map, and I can go look up the value and use it, or go ahead and set some value with it, some kind of object with it. So again, I can do this over and over. Now we'll do something similar in Node and the Express framework soon with something called session-oriented middleware, and we have example code for that and all that, and we'll do that, and that session-oriented middleware will allow us to kind of drop in this management of stateful object-oriented information that I can look up every time a new request comes in and say, hey, I've already been talking to the user at this browser before, and can I get the conversational state information, the session information associated with that specific conversation. Best practices, the state management technique matters. Typically nowadays, I mean, I showed you old school ones. I have an example in Node Info that I can show you in a minute for the hidden solution. There's URL rewriting. Hidden solution is too easy to break and too easy to steal. You can do a view source, right? And you can see what the hidden values are. URL rewriting is better because it's at least encoded on the URL, and there's a lot of proprietary and hard to break schemes. But still, the information is going over the wire again, so it's always going to have an inherent risk that is greater. Cookies are better than URL rewriting, but they're possible to steal those as well. And again, they're unwieldy, meaning they may persist beyond the bounded interaction that we want. And once they stick around longer, that means they're susceptible to getting stolen by other processes or by other users that come on and use a shared computational resource. SSL sessions actually in a sense are the best because they provide a connection-oriented type semantics to your connectionless
your default connectionless, and connection-oriented stateful kind of go hand in hand. They're easier to use together. But that's the real thing is not just they're a pain from a user experience and scalability standpoint. The real reason is, unintended. This isn't the use case for SSL sessions. It's a side effect. Anytime you use something for a side effect, you're actually creating more stress in the architecture of your system, more dependencies on it, which lowers your flexibility. So SSL sessions really aren't the best mechanism. The real best practice is, again, use a framework. This is one where rolling your own by doing one of these three or even the fourth one isn't really the way to do it. I show you these things so you understand how some things work. But at the end of the day, using a tried and true and tested framework or library or toolkit that's appropriate to the language and software platform you're using is the best approach. All right. Make sure your session IDs are not based on security or privacy info, or that they're temporal GUIDs. GUID is a global unique identifier. Make sure that your conversations need to expire, is why number 3 is on here. What does that mean? Again, I'm going back and forth, right? I'm on a shopping site. I go and enter my payment info, and I'm right on that page. I'm here in my browser. This is the browser server side, and I'm at this final confirm dialog. But guess what? I got a phone call, or I forgot to hit submit, and I just got up and left the computer. If I just leave it there forever, right? If anybody else walks up, again, my conversation is open. It's never been terminated, right? And the server's sitting here hanging on to some resources, wondering if that conversation will ever finish. So what servers typically do is they implement a timeout. And that timeout can be, a default can be anywhere 5 to 30 minutes. And you've seen this on a website. If you go and you don't interact with your banking website, your e-commerce website, when you're in the middle of a conversation with it for a certain number of minutes, you normally get a warning saying, hey, are you still there? Are you going to finish this or what? And it usually has a click on a JavaScript or something, so it can turn around and tell the server, yes, somebody's there, they just are paused for some reason. Because otherwise it's just going to time out and send you back to the landing page because it's worried about security, and it's also worried about a leak of its resources. All right. So typically we have some kind of temporal ID and temporal attribute of our conversation that says, hey, if you can't finish the conversation in this time, or if you let the conversation go quiet for this gap in time, as a server, I'm just going to unilaterally cut it off. Because now I'm afraid you forgot, I'm afraid I'm leaking resources, I'm afraid of a security hack where somebody else is going to come in and try and hijack the conversation because you never finished it. Okay. Summary: conversational state is a bounded interaction between a client and the server, the web browser and the server. Several techniques exist for maintaining conversational state, though some are legacy, like hidden form fields and URLs, and all of them have different issues. They all have pros and cons, right? Again, hidden form fields and URL rewriting are portable. They worked in 1995, they work in 2018, they'll work in 2040. I mean, those things will always work. Cookies typically always work nowadays as well, but again, cookies have the problem that someone may not manage them properly, so they're longer lived than our bounded conversation. They also have the problem that the end user could actually block them and render your site non-functional, and also create security risks in doing so. There's, again, frameworks that we typically want to use for conversational state. This is an example where we don't want to roll our own. And then you might read, if you go out and you're starting to read about session, you might hear this word session with storage on browser side, on HTML5 clients. And is that the same? Well, we're going to talk about the client side. It actually isn't the same. Not that you couldn't potentially use this for conversational state, but the word session here actually means something different. And we'll talk about that when we get to the browser side. I don't want to talk about it now, but I wanted to point it out in case you come across that in your reading. Don't think of this as the same thing, not the same kind of sessions we're talking about when we talk about a session API. This is server side. All right, this is browser, and to be discussed later. Conversational state is the most important form of state for application developers on the web and understanding where that is, but it's not the only form of state. As we mentioned up front, understanding your application state at runtime, what happens if your application crashes, gets restarted, gets evolved to the next version, those kinds of things, life cycle of your running processes. Universal or world model state is incredibly important. It is application independent. It's really that big database of organizational information that's very sensitive to use across all your applications. Your role as an application developer and playing nicely with that world model state is very important, but is not really the subject of conversational state. And then we have user preferences state, states pertaining to a user's profile that may inform the interactions, but are not the conversational state itself. User preferences state is typically done, or at least involves cookies. And each time, sometimes you have the entire profile stored in preferences in a database on the server, sure. But in general, that notion of I return to a site and knows who I am is typically done by a cookie. Now remember, you might say, well, okay, you see this in GitHub. You go to it and it typically remembers who you are. So does Amazon when I go to it. But when I go to buy something on Amazon, or I go to do a sensitive operation, a write-oriented operation on GitHub, like add a new collaborator or create a new file, it asks me to re-authenticate. Why does it ask me to re-authenticate? Well, from a user experience perspective, it was trying to say, I remember who you are coming from this browser, and I'll set the preferences that way. But when you do something sensitive, I better confirm it's really you, as opposed to making a guess. In fact, on a lot of websites, you'll even see, you'll see this this little thing, it says "Hello, Kevin" in the upper right. Amazon does this, and underneath it, it might say something like "Not you?" ? Why does it say that? Because it's set a cookie to think that it's you because you're using a browser you used before. But in fact, maybe somebody borrowed my laptop, maybe my kid's on it or my wife's on it, and they want to buy something, and it says "Not you." Well, they should click that, and it's going to basically ask them to re-authenticate as somebody else and probably reset that cookie. That's why you see links on that on some websites. Okay. In the event, this is the overview of conversational state. There is an example of the echo headers where it has both a cookie and an input. It doesn't do URL rewriting, but it does have an input form. So this is an input tag inside a form that gets output, and it has a type of hidden and a name of hidden parameter and a value in there. Okay. If I go run this, and I'm already running this program, if I open up a browser and I go to this, let me bring this into focus, and I go to that application, right? What do I have? It's outputting the cookie when you look at the code. Right now the cookie's undefined because I'm going to the site for the first time, so it hasn't set anything. And then I can type in something. All right, what I type, it's not even, this is generic. But if I, before I do that, if I even view source on there, right, I have this input type equals hidden. Now you see the input type equals text, name equals name. You already see that on there, and you see the submit button already rendered on the page. But even though I have an input tag here, there isn't anything rendered, right? That hidden is not viewed, right? That's what hidden means. You don't see it. So I type something in and I send OK, right? And I get back what this particular page does. But notice that it's even sending in its query string, in its payload, this notion of a hidden parameter of "Do you see me?" All right, that's what Node got on the back end for that particular example. So this is the Node Echo HB Echo headers example. The modified Echo program has a simple use of doing a cookie. The cookie sets a timestamp based on what now is when it received the request, and it sets as part of the payload what comes in is the hidden parameter in addition to the thing you actually typed in. All right, very simple example, and you can use those mechanisms, but again, you have to keep sending this information back and forth between the client and server to make it happen. Going forward, we will use, in week 3, we'll start using, as we use frameworks, we will use session-oriented middleware, and we'll still have use cases for cookies based on user preferences state. We won't really use hidden form fields or URL rewriting, but I wanted to make you aware of these legacy things and how things evolved to session-oriented middleware. We didn't always have session-oriented middleware, but as these use cases became more prevalent, as the web went from a document platform to an application platform, there became more of a need for session-oriented frameworks, and therefore all major platforms now provide it.